I'm Josh, this is Newtons per second. Welcome everyone. This is part 4 to Journey to Level 3 certification. In this video, I cover the electronics bay construction and drilling holes for bolts and shear pins. And to me, that's a big deal because it's the last part of the airframe before I can start painting, which is exciting. Painting, decaling, making this rocket really look complete. So we'll get started. Here we go.
All right, we have the sled all marked out, ready to cut out. So here's the main sled, and here are the brackets that the threaded rod will be going through to hold this in place in the electronics bay. All right, let's get it cut out. Alright, here is the sled all done. You can see my 3D printed channels I put in to help organize these lines. Here's the Easy Mini altimeter, the RRC3. And what I do, I like to mark these channels, the Pyrotechnic channels. You know, there's the Easy Mini Drogue, RRC3 Drogue. Over here is main, main. I got them all labeled, even on the bulk plate. So this isn't a really super complicated sled. This is really basic, but you can see how those are, the brackets are like keyed in and glued. Here's the rail, or the threaded rods, and then making the brackets to hold the threaded rods I also use as a battery holder. So there's two LiPo batteries in there, and this works out really well. And again, nothing fancy. I just zip tie them on, and that's fine. And here's what the other side looks like. And I've already at this time tested out charges. You can see a little char mark there. But these are stainless steel U-bolts. The wire coming through the bulk plate, I just use hot glue to seal it. And here are the rotary switches already installed into the vent band. And what else? These are just PVC caps that I use, terminal blocks from Chris Rocketry. So, like I said, nothing too fancy, but I do enjoy making my own electronics bay from scratch, cutting the bulk plates out by hand. These connectors are just got from Amazon. And a shout out to Bob Valding, my friend, who bought me these LiPo batteries. Try to get me away from using 9 volts. I'm really going to enjoy these. Just hook them up and charge them, and that's going to be a lot easier to deal with than worrying about 9 volts and constantly buying another 9 volt battery for a new launch or something like that. Alright, I'm outside. I am working on all my marks to drill. Here are going to be the Missile Works, those rotary switches. Two right here. Is my vent band, or the vent hole, excuse me. Those are vent holes. His witness marks. These are marks for the T-nuts. So I'm going to be holding on to this airframe here. Slide it on, T-nut to hold the upper airframe. And then I opt in to have the midsection tube. Same thing, T-nuts here. So I'm marking my spot to put those in. And that's going to allow me to take apart this rocket for easier transportation. I was just going to epoxy this midsection on the coupler here, but that's going to make a 60-inch section here, and which would be harder for transport. Also, the other problem is the upper centering. So you have the coupler is glued in here, epoxied, and then the upper centering that holds the U-bolts are right here. If I epoxy this in place, once I get the quick links to the U-bolts and the harness tied in, I'm not going to have access to it if I need to change that out. So that's a problem. So by having the T-nuts in here, I will be able to take out the bolts, slide the midsection airframe, and have access to the quick links and the shock cord down here if I need to service something. So what else I did before I start drilling the holes is you can see like these spots down here, wet spots. Those are super glue, and when you drill through the stiffy tube, it tends to just kind of fray and not really make a clean hole. So I'm hoping let the super glue soak in and harden. When I make the hole, when I drill through, it will be somewhat clean and be easier to straighten out. And I also did that where the T-nuts are going to be going through on all 4 sides. Did that on the booster, and also, like I said, on the coupler. So let's see if that helps.
Alright, that wraps up part 4 of this series. The next video will cover the nose cone construction, where I take the lock nose cone and I cut the bottom of the shoulder off where you have that plastic loop, and I kind of retrofit it with a payload section, a couple of center rings, and I do some more reinforcing to make sure this thing is solid, more than the previous Jupiter 3. There's heavier threaded rods in there and quite a bit of work. So that video will just cover the nose cone, and I'll show you guys that. It is similar to the other Jupiter 3 rocket, that process, but I added some extra steps, and I think this is much beefier because it's a lock nose cone, it's plastic, and everyone knows the epoxy has a really hard time sticking to plastic. So I did some extra things, and I think it's going to be 100%. The other Jupiter 3 nose cone that I did, it's still holding fine, but there's only one point where I only have one centering in it, where this has two, and like I said, I did some extra reinforcing, so it's super heavy duty lock nose cone. Part 6 will wrap up the build series before I get into test flights when that happens. Thanks again for watching this video, and we'll see you guys next time.